lasers have always been the favorite weapon of science fiction space battles.
The idea of having a personal laser is just fascinating and attractive. I would have loved one at the age of 12 myself. It's the same way that kids sometimes want to be cowboys and gunslingers. There's something very fun about the idea of having a weapon that is quick, painless, instantaneous, and makes you the toughest SOB in the valley.
But what exactly is a laser?
Lasers can be thought of as sort of a high-tech flashlight. But all the waves are in phase, so you've got all the wave crests lining up. So that makes the radiation really intense for a given amount of power. See, normal light from a flashlight or from the sun is all out of phase. It's incoherent. Some wave crests are like this, the wave troughs of other waves are like that. They tend to largely cancel out. And what you see is the leftover parts that didn't cancel out.
Most visible light laser beams appear as a certain color, since only the light in that specific color frequency is lined up and coming out of the chamber. And different types of lasers can damage targets in different ways. This green light laser at Stanford University's high-power laser lab pulses on and off in powerful bursts.
Is actually not delivering a lot of heat. What it is, though, is a very strong electric field. And this one can provide a strong enough electric field. By creating a high electric field, you can rip apart atoms, you can rip electrons off of atoms if you wish, and you can break down materials.
The strong electrical field even rips apart air molecules. They come back together between each pulse.
And that's when you get this flash, that's when the energy comes out, and you see the light, and you get the report that way, much like thunder and lightning.
And these strong fields are especially good at knocking out electronic equipment. In fact, the laser beam is so powerful, it actually damaged our camera as we recorded these images, when dust particles deflected part of the pulse into the lens. It left a permanent green imprint on the camera's light-gathering CCD imager. Another laser at the lab demonstrates the power of continuous waves instead of pulses. It's an infrared beam, so it's not visible to the human eye, but its effects certainly are.
It's very similar to the one that military is developing, only the military is about 50,000 times stronger. Right here we have a lens, and so as we go through the lens, the beam is focusing down in this plane here. If I put a target in that plane, you can see that we end up burning it because of the heat. And I can then take out a nice smoothly edged piece of cardboard from this cardstock.
The laser weapons of future space wars would likely work in the same way, but sci-fi movie fans may be very surprised to find out how real laser weapons will actually work in space.
In science fiction, we often see a laser bolt, a bolt of energy, whereas in reality, with a laser, you would see a beam connect, then disconnect. I mean, light is the fastest thing we know of.
If you were to see someone about to shoot you with a laser beam, you would have to react very quickly when you see their finger beginning to twitch toward the button. Otherwise, you'll get zapped the same time that you see the zapper initiate the zapping.
But in a duel in the vacuum of space, even the beams of laser weapons using visible light won't be seen.
So the reason that we can see this beam here is that it's scattering off of the dust particles in the air. In space, there are no dust particles, it's a vacuum, so you wouldn't see the beam except for at its target and reflections off of its target.
And since sound can't travel through a vacuum, none of those cool sci-fi laser sound effects will be part of a real laser battle in space. But even though laser weapons in space won't look and sound like they do in the movies, they'll still be fast and deadly on the battlefield. So what will a real space dogfight look like? You'll have to see it to believe it. No weapon has fascinated generations of science fiction fans more than high-energy lasers.